Expecting you put it where the sun is, it would loosen up to the circle of Jupiter. A beast, absolutely flimsy, is going to detonate. These are among the most recognizable effects of radio energy in the whole universe, conveying more energy than a billion suns. Uigu, or the surprising Crawley Jew, is a red giant star. If you placed it where the sun is, it would reach the orbit of Jupiter. Immense, totally conflicting, and nearing detonation. This star challenges our understanding. When we ponder stars, we no doubt envision immaterial twinkling things in the night sky, essentially how we see them from down here on Earth. Yet stars are something entirely different in reality. Perhaps one of the most noticeable stars, Betelgeuse, is essentially more massive than our sun. For a surprisingly long time, this star has bewildered generations. Believe it or not, something extraordinary and troubling has been going on with Betelgeuse, causing scientists and astronomers to become deeply concerned. Join us in this discussion as we explore the amazing new information about Betelgeuse, its imminent annihilation as predicted by the James Webb Space Telescope, and how this development might affect our universe and our lives on Earth. As explained by physicist Michio Kaku, Betelgeuse is a monstrous wonder, a giant star that has fascinated astronomers for decades. A Greek space master named Antonius was the first to document it. This star is so immense that it can be seen in the night sky from Earth, especially during winter. If you're interested in cosmology, you've likely heard of Betelgeuse, the reddish-orange star marking the upper left shoulder of the Orion constellation. This star is ancient and remains one of the most sublime stars in the night sky. However, one startling feature of Betelgeuse's brilliance is its variability. It doesn't remain constant, but instead fluctuates. This change is one of the star's extraordinary properties, though not the only one. Let's explore some of Betelgeuse's unique traits. Most stars visible in the night sky are far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. To grasp this distance, imagine traveling at the speed of light, 186,000 miles per second, for an entire year. Light can cover immense distances, equivalent to 1 light-year in that time. Doing the math, the closest star would still be billions of miles away. Betelgeuse, by contrast, is around 600 light-years from Earth. If we could somehow travel at the speed of light, it would take 600 years to reach it. Despite this vast distance, Betelgeuse shines brightly in our sky due to its exceptional size and qualities. Betelgeuse is significantly larger than our sun and so immense that it appears as a disk in space when viewed through advanced telescopes, unlike most stars, which appear as tiny points of light. Betelgeuse is believed to be between 12 and 19 solar masses. A solar mass is the standard unit of mass used by astronomers, equal to approximately 2x10 superscript 3 kilograms. Experts cannot pinpoint Betelgeuse's exact mass because it lacks orbiting planets to measure against, and direct measurement from Earth is impossible. Still, this makes Betelgeuse several times heavier than our sun. The star's brightness ranges from +0 to +1.6 magnitude, making it far brighter than our sun. It is no surprise that it earned the nickname Red Giant. Yet Betelgeuse's nature is unstable. It pulsates, expanding and contracting. When it expands, it becomes brighter. When it contracts, it dims. This cycle can last anywhere from 10 to 100 days or longer. A fascinating property of Betelgeuse is its surface, which is covered in dark magnetic spots. These spots have magnetic fields much stronger than the sun's, disrupting the flow of hot gases to the star's surface and causing it to cool in these regions. While our sun also has magnetic spots, Betelgeuse's spots are much larger and more numerous. Some are twice as wide as Earth. Betelgeuse's magnetic field is thousands of times stronger than the sun's, causing gases on its surface to appear to swirl and spin. Its surface temperature is around 3,500 K, contributing to its red color and relatively low energy output compared to its size. Interestingly, Betelgeuse was not always red. It was once yellowish, like our sun, and began transitioning to red around 1,000 years ago. This color change has led scientists to believe the star is evolving. Betelgeuse emits several times more energy than the Sun. If it were closer, it could easily compete with the Sun as a source of light and heat for Earth. Despite being 600 light-years away, Betelgeuse is visible to the naked eye, a testament to its immense size and power. If it were as close as the Sun, it would engulf or displace Earth and the other inner planets due to its massive size. Betelgeuse is a remarkable giant star located in the Orion constellation, about 600 light-years from Earth. Its enormous size allows it to appear as a disk rather than a point of light when viewed through telescopes. Though massive, it is not the largest star known. Its mass ranges from 12 to 19 times that of the Sun. Despite its size, Betelgeuse is not the densest star. Its massive outer layers are spread out, giving it a low average density. This is one of the characteristics that make it a red supergiant, a stage in a star's life that marks its impending collapse. Over time, Betelgeuse has lost a significant portion of its mass through stellar winds, which carry its outer material into space. This process creates a surrounding cloud of dust and gas, further obscuring its exact size and shape. One of the reasons Betelgeuse fascinates astronomers is its imminent fate. Betelgeuse is nearing the end of its life cycle and is expected to undergo a supernova explosion. When this happens, the star will briefly outshine an entire galaxy, emitting a burst of energy visible from Earth even during the daytime. This event, though spectacular, poses no direct threat to us due to the star's distance. However, the explosion will be a groundbreaking opportunity for scientists to study the life cycle of massive stars and the formation of heavy elements in the universe. The James Webb Space Telescope and other advanced instruments have been monitoring Betelgeuse for signs of its impending collapse. Over the past few years, astronomers have noticed unusual dimming events, leading to widespread speculation about its condition. Initially thought to be a precursor to its supernova, these dimming events were later attributed to massive clouds of dust expelled from the star's outer layers. Despite this clarification, the fluctuations in Betelgeuse's brightness remain an active area of study. As Betelgeuse prepares for its explosive finale, it serves as a reminder of the dynamic and ever-changing nature of the universe. Its supernova, when it happens, will not only mark the end of a star, but also the beginning of something new. The explosion will scatter heavy elements, such as iron and gold, across space, elements crucial for the formation of planets and life. Betelgeuse's story is a testament to the cycles of creation and destruction that shape the cosmos. Though it may seem distant and otherworldly, its processes are directly connected to our existence. Stars like Betelgeuse are responsible for forging the building blocks of life. Every atom of carbon, oxygen, and nitrogen in our bodies was once formed in the heart of a massive star like Betelgeuse. The impending death of Betelgeuse will be an astronomical event for the ages. Its supernova explosion will provide valuable data, reshape the Orion constellation, and offer insights into the future of our own sun, which will eventually become a red giant, albeit on a much smaller scale. While we won't witness the sun's transformation for billions of years, Betelgeuse gives us a glimpse of what lies ahead. In the meantime, Betelgeuse continues to be a subject of fascination for scientists, astronomers, and stargazers alike. Its fiery glow, visible in the winter sky, serves as a beacon of curiosity and a reminder of the grandeur of the universe. As we wait for its final act, we can marvel at the beauty and mystery of this incredible celestial giant, whose legacy will live on long after its light has faded. In mass, the challenges engaging are due to the difficulty of precisely assessing the mass of stars. These stars often need companion stars or other objects to serve as gravitational reference points. Truth be told, even at its lower estimated mass, Betelgeuse remains a colossal and superb celestial body. The brightness of Betelgeuse is another vital characteristic. It changes consistently over time, with its magnitude ranging from 0 to 1.6. For comparison, a magnitude 0 star is approximately 2.5 times brighter than a magnitude +1 star. At its brightest, Betelgeuse can be several times more luminous than our sun. This variability is attributed to its pulsations, periodic expansions, and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for years, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring about 3,500 Kelvin. This gives it a distinct red tint, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy, causing the star to expand outward. The star's atmosphere is rich with complex physical phenomena, displaying dark magnetic spots on its surface where the magnetic field is stronger than in surrounding areas. These spots inhibit the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a giant, brilliant star. However, it will ultimately meet its end in a catastrophic supernova explosion. Betelgeuse, as a massive star nearing the end of its life, is destined for a dramatic finale. When it runs out of fuel, it will undergo an extreme fusion cycle, producing heavier elements like helium and carbon. This process will cause the star to expand, potentially reaching much greater sizes, making it one of the largest stars visible in the night sky before it dies in a colossal explosion. A supernova marks the death of a massive star. The energy released during such an event is immense, surpassing the total energy our Sun will emit throughout its lifetime. This type of stellar death leaves behind a remnant, which could either be a neutron star or a black hole. The eventual demise of Betelgeuse will have widespread implications, but these effects won't be felt on Earth for thousands of years. This is because, despite the star being relatively close in cosmic terms, its distance of approximately 600 light-years means the effects of its eventual death, such as the explosion and radiation, will take centuries to reach us. As Betelgeuse approaches the end of its life, it will enter a critical phase known as the supergiant phase. During this time, it will continue consuming heavier elements in its core. As fusion progresses, it will produce increasingly complex elements such as carbon, oxygen, and eventually iron. Once iron fusion begins, the star will have reached the limit of its energy production capabilities. This marks the onset of core collapse, leading to a spectacular event known as a supernova. In the final stages of its life, Betelgeuse will undergo violent fluctuations, expanding and contracting with extreme intensity. These oscillations will cause the star to shed its outer layers in powerful eruptions, forming a cloud of gas and dust. These materials will scatter into space, enriching the surrounding cosmic environment with elements essential for the formation of new stars, planets, and even life. This process of mass ejection can last for thousands of years, but eventually, the core will collapse inward under gravity, resulting in a supernova. The supernova itself will be a dramatic release of energy, outshining entire galaxies for a brief period. It will emit an immense amount of radiation and particles, which could influence nearby systems. However, due to the vast distance of 600 light-years, this radiation would not significantly affect Earth. It is important to note that while Betelgeuse's eventual explosion will be spectacular, it is far enough away that it poses no direct threat to our planet. However, it may alter the appearance of the Orion constellation. After the explosion, Betelgeuse's remnants will likely become either a neutron star or a black hole. If the core's mass is large enough, it could collapse into a black hole, an object with such immense gravity that not even light can escape it. On the other hand, if the core isn't massive enough to form a black hole, it will create a neutron star, a highly dense object composed primarily of neutrons. The consequences of Betelgeuse's eventual death will be significant for astronomers and astrophysicists studying stellar evolution. This event will provide valuable insights into the life cycles of massive stars and their impact on the surrounding universe. For humanity, It is unlikely that we will witness this event firsthand, as Betelgeuse's explosion is still thousands of years away. It remains a subject of distant cosmic fascination rather than an imminent threat. Nevertheless, Betelgeuse's death will have profound effects on the structure of the Milky Way. As the supernova ejects its materials into space, it will contribute to the formation of new stars and planetary systems, enriching the galaxy with heavier elements. The explosion may even trigger the birth of new stellar nurseries in the surrounding molecular clouds. The ashes of this giant star will continue to fuel the cycle of life and death in the universe, ensuring that the cosmic process of stellar birth and demise continues unabated. Thus, while we may not feel the immediate effects of Betelgeuse's end, its eventual explosion will leave a lasting imprint on the history of the universe. It will serve as a reminder of the immense forces at play in the cosmos and the transient nature of stars, even the largest ones. Betelgeuse's death will be one of many cosmic events shaping the universe as we know it, paving the way for the birth of new stars, planets, and perhaps life itself. The story of Betelgeuse's eventual demise also highlights the cyclical nature of the universe. Stars like Betelgeuse play a crucial role in the cosmic ecosystem by creating and distributing the heavier elements necessary for life. These elements, such as carbon, oxygen, and nitrogen, are forged in the cores of massive stars and released into space during their violent deaths. This process, known as stellar nucleosynthesis, is the foundation of the chemical complexity that enables the formation of planets and the development of life. Without the contributions of stars like Betelgeuse, the universe would lack the diversity of elements required for the emergence of complex systems. Betelgeuse's journey from a massive star to a supernova and its aftermath as a neutron star or black hole is a small but significant chapter in the broader narrative of the cosmos. Its life and death serve as a poignant reminder that even the most magnificent celestial objects are transient, their existence shaping the universe for the generations of stars and systems that will follow. For astronomers, observing Betelgeuse offers a rare opportunity to study the late stages of stellar evolution in real time. Its variability, size, and proximity to Earth make it a perfect candidate for ongoing research. Advanced telescopes and observatories around the world are closely monitoring Betelgeuse, searching for subtle changes that could indicate the star's progression toward its dramatic end. While the exact timing of Betelgeuse's supernova remains uncertain, its eventual explosion will undoubtedly be one of the most significant astronomical events witnessed by humanity, if it occurs within our species' lifetime. When it finally happens, Betelgeuse's supernova will be visible from Earth, even during the daytime, as it temporarily outshines all other celestial objects in the sky except the sun and moon. In the meantime, Betelgeuse continues to inspire wonder and curiosity, both for scientists and stargazers. Its vibrant red hue, its massive size, and its unpredictable brightness make it one of the most recognizable stars in the night sky. Situated in the constellation Orion, it serves as a beacon for those exploring the cosmos from Earth, a reminder of the vastness and beauty of the universe. Ultimately, Betelgeuse's story is a testament to the dynamic and ever-changing nature of the cosmos. It illustrates how stars, planets, and even galaxies are interconnected in a cosmic dance of creation, evolution, and destruction. As Betelgeuse nears the end of its life, it stands as a symbol of both the fragility and resilience of the universe, where the death of one star can give rise to countless new possibilities. The legacy of Betelgeuse will endure long after its light has faded, written in the elements it leaves behind and the new stars and planets that will form from its ashes. It reminds us that while individual stars may be finite, the universe itself is a place of infinite potential, where the cycle of life and death continues, shaping the cosmos in ways that are both profound and awe-inspiring.